Some routers and firewalls are configured to not pass ICMP echo requests or echo reply requests. Attackers sometimes try to map out remote networks by pinging all the possible addresses and collecting replies. So blocking this type of traffic at the perimeter is fairly common. Just because you do not receive a reply to a ping does not necessarily mean that the host is not available. Traceroute is a computer network diagnostic tool for displaying the route or path of packets through the internet between your computer and a specified destination computer. It also measures the amount of time each hop took. When you run the utility, it initiates the sending of a packet, including in the packet a TTL, a time-to-live value, which is also known as a hop limit. As the packet passes through a router, the TTL is decremented until when the TTL reaches 0, the packet is destroyed and an ICMP time exceeded message is returned. Traceroute works by setting the TTL for a packet to 1, sending it towards the requested destination host, and listening for the reply. When the initiation machine receives a time-exceeded response, it examines the packet to determine where the packet came from. So this identifies the machine 1 hop away. Then the tracing machine generates a new packet with TTL2 and uses that response to determine the machine 2 hops away, and so on. The command traceroute is available on many modern operating systems. On Unix-like systems such as FreeBSD, macOS, and Linux, it's available as a command line tool. On Unix-like systems, Traceroute sends, by default, a sequence of UDP packets. Traceroute is also graphically accessible in macOS within the Network Utility Suite. In Microsoft Windows, it's named Traceroute. In Windows, Traceroute sends ICMP echo requests instead of UDP packets. For IPv6, the tool sometimes has a name Traceroute 6 or Traceroute 6. Let's look how the Traceroute command operates in our host machine and virtual machines as well. So I'm on my host machine. This is Mac OS. And I'll open a terminal screen, Command Space to open the Spotlight search bar, and type terminal. Start the terminal app, and now I'm on a terminal screen. Traceroute is the command I'll use. So if you run it with no parameter, you get a brief help about the usage of the command. So now let's run the command with a target host. We timed out in the first hop. And in the second one as well. Well, it happens, no worries. And yes, here are the other hops. This is the path that the packets follow from my host machine to the target web server. In macOS, you can also trace the packets with a graphical UI, which I mentioned before. So go to the Network Utility tool, press Command and Spacebar once more to open Spotlight, and type Network Utility and find it and open it. There's a Traceroute tab in the Network Utility window. Just type the target host and click the Trace button. Let's see how it all works in Kali. So now I'm in Kali and I have a terminal screen open. Type Traceroute and hit Enter. So you'll see the help for this particular command, and it's a bit more detailed than the one in macOS. So now I want to show you the network configuration of my Kali. Go to Kali Settings, click Network Adapter, and as you see, we run Kali in NAT mode, where the host machine, Mac, provides network address resolution, we'll talk about that soon, for all network traffic, and Kali shares the IP address of the host. Now I want to test the network connection first. So I'll ping the Google DNS 8.8.8.8 And, right, that's no problem at all. You can use Control-C keys to end the ping command. Just don't use Control-L. Okay, now I'll run the traceroute with the target host in Kali. The first hop is a gateway prepared by VMware for my virtual machines. And as you can see, all the other hops are blocked. We cannot trace packets from the VM in NAT mode. So let's have a look at the traceroute command options once more. Here there's an option, uppercase T, which sends TCP SYN packets. Now I'd like to try the command once more with this option. Okay, so we have the first and the last hop this time. So now I want to show you the command in a Windows system. Here is my up-to-date Windows 8 system. It has an IP. Check the connection, ping, and yes, the network is running. Good, just where we want it. Let's look at the network details first. From the Network and Sharing Center, click Ethernet 0, and then the Details button, and here are the details. Default gateway is 99.2, DHCP is 99.254, as you know. These are the devices prepared by VMware for our NAT network. So now I go to the settings of the VMware Fusion. In Network Adapter, we confirm that the VM is in NAT network mode. Now I'm in the command prompt. As I mentioned, the command is Traceroute in Microsoft systems. So write down the target host and press enter. So the first hop is, again, the gateway. And just like in Kali, since this VM is also in NAT mode, the requests for other hops are timed out. So while the command is running, I'd like to show you the command help. So just type Traceroute and hit enter. So we didn't enter the host this time, and here's a usage of the Traceroute command. Trace completed, and there is no result given, as expected, because we're in NAT mode. I know you knew that, but I just wanted to make sure. So now I'm going to run my Windows VM in bridge mode and try the command once more. And once again, click the hardware settings icon on the menu bar of VMware Fusion and select Network Adapter. So I'm using Wi-Fi to connect to the internet right now, so I choose Wi-Fi under the bridged networking section. Now this is the IP address assigned by the DHCP, and the subnet mask of the network, again, is set by DHCP. So we'll see how the DHCP works. Just stay with me here. So as you see in the Network and Sharing Center window, the active network disappeared as soon as I changed the network adapter of the VM. In a second, the new network is activated. Click Ethernet 0 and look at that, the Details button. So click on that to see the network settings, and those are the new ones. So now we're in the 192.168.12.x IP block. And we have a different DHCP and gateway run by the network admins of my office building. So let's go back to the command prompt and trace the route of the packets once more. So first I want to check the network, as I always do. So I'll ping the Google DNS, and yes, we have the internet connection. So now is the time to trace the route. The first request is timed out. Remember, the results of my host machine, right? The second request timed out as well. And here are the other hops. We now have the results.